So we're looking at the very end of this lesson now. It says it is also good to be able to place, I'm reading exercise 5, to place sums into sigma notation. The values that are being summed in the next problems form either an arithmetic or geometric sequence. So first we're going to look back at exercise 1 on the previous page and decide which problem represented the sum of the terms in an arithmetic sequence and a geometric sequence. So going back to this page, if I look through these numbers I added, this one with the fractions is definitely not arithmetic or geometric, nor is this one. This doesn't really have an adding or a multiplying pattern. But here, this is times 2, times 2, times 2, times 2, okay? And we see, so this is geometric. This is technically geometric because we're multiplying by -1 each time, but I'm going to kind of ignore that one for now. And then this one, plus 2, plus 2, plus 2 is arithmetic. So technically D is also correct, but we're going to focus on C and E. Now, what you'll notice here is that this formula is set up in our A sub 1, right? Our A sub 1 is 3 times B, our common ratio is 2, to the n minus 1, but we use j minus 1 here. Down here, we'll notice this one, it's kind of backwards, but I'm going to start from this 2. This is the difference times n minus 1 plus a sub 1. It's just that the 1 is written in front. So this is written a little differently, but we can recognize those formulas. We know those explicit formulas from the first lesson. So we saw the arithmetic sequence was in part E. And the geometric was in C, and technically D also, but that one isn't really written in that form that we're used to, so we're not going to focus on that one. So what we're going to do now is kind of work backwards and look at sequences that are either arithmetic or geometric and say, how could we write these sequences? And these are actually called series because we're adding the numbers in the sequence. So series, we'll use that word more in the next lesson. But that's the term we use when those numbers, instead of having commas, have addition or subtraction between them. So let's look at our first one. We have 40, 28, 16, and so on. So if I look at this one, I notice that I have an arithmetic pattern where we're subtracting 12 each time, okay? So first off, we're going to write a formula for that. So in this function, or this sequence, our common difference is -12. We multiply that times n minus 1. Remember, it's shifted over 1. And then our start value is 40. So that's just using my formula D times n minus 1 plus a sub 1. Okay, and that's for the arithmetic series. Now, in order to write this as a summation notation, I basically just take my formula without the a sub n and write it next to a sigma notation. There will be one step past this. I'm going to use n. I could use I or k or some of those letters that we've seen. Now, in order to say all of this is in the sum, I do need parentheses around it. Okay, otherwise, actually, the 40 won't be included in the sum, but we want to repeat that 40. Now, when we write what goes on the sigma notation, the numbers, to match up with the fact that we call the first term a sub 1, I always put a 1 on the bottom. That's not true when you're starting with a problem that's given to you, but when we write our own, okay, that's always a 1 on the bottom. Now we need to figure out how many terms there are. So there's various ways to figure this out. I'm just going to write in the missing terms. So if I continue this pattern of subtracting 12, I have 40, 28, 16, minus 12 would be 4, okay? Minus 12 again would be -8. Minus 12 again would be -20. So I have 1, 2, 3, 4, 5, 6 terms. So when I do this formula, I would need to plug in a 1 through a 6. So the number of terms goes up top, and then a 1 is always on the bottom when you write your own. Right, so let's look at another one. So basic gist is write your formula, and then the number of terms goes on the top, and you start with a 1 on the bottom for the numbers we plug in. So looking at this next one, letter B, this looks like it is geometric. When I look at this one, So here, I'm going to divide. Actually, down here I can see even better. I'm pretty sure I'm multiplying by 5. But to be absolutely positive about that, I'm going to divide. So I'm going to do 1/5 divided by 1/25. The second term divided by the first term. Sorry, we have a phone in here. So dividing this out, that does give me 5. And that's my common ratio. And as I said, we can also see it between those two terms. And if we think through, we can see we're multiplying by 5. So once we figure that out, we're going to write our formula next to the sigma notation. So my formula for a geometric series is a sub 1, which is 1/25, times b, which is 5, to the n minus 1. Now, parentheses, since we don't have addition in this one, parentheses actually isn't necessary. But just to kind of like not have to worry about when you need it and when you don't, I'm just going to put the same parentheses in there. So on the bottom, we are always starting with n equals 1. And there are 1, 2, 3, 4. And if I continue this pattern, the next number would be 25. And then 125 and the 625. So this has 1, 2, 3, 4, 5, 6, 7 terms. Okay, so that's how I would write that out. I would suggest trying the next two on your own. And then checking on the video. Okay, so hopefully you've tried them on your own, and now we're going to go over them. So this one is arithmetic. We're adding 3. So my formula is, I'm going to write that sigma notation. We have d is 3 times n minus 1, plus a sub 1 is -6, so I'm just going to write -6 there. We're going to keep it in parentheses. And then we're starting always with a 1. And to follow this pattern, if we filled in the extra terms, -6, -3, 0, 3, 6, 9, 12, and then we'd have the 15. So this one has 1, 2, 3, 4, 5, 6, 7, 8 terms. So we put an 8 up top. So that is my final answer for that one. The next one, we have a geometric pattern. We are multiplying by -3, because anytime we have those flat flip-flop of the negative and positive signs, that's what's going on. So here, I'll write my sigma notation to represent the sum. We're starting with -2, multiplying by -3, and then to the n minus 1. So we're starting out with the first term. And here, if I write in those numbers, we would have 54, -162. This is just continuing to multiply by -3, 486, and then we'd have the 1458. So this one also has 1, 2, 3, 4, 5, 6, 7 terms. So I put a 7 up top. Now, if at any point you're confused about where these formulas came from, just remember that's the very first lesson if you look back at those explicit formulas that are really similar to mx plus b or a times b to the x.